Okay, this is Meaty Prob number 1. We're going to find the area outside the first curve, inside the second. So the curve's going to be cosine theta, and the second is going to be r equals 1 plus cosine theta. Okay, so when you graph this, it's going to look something like this. So it's a bad circle, but it should be a circle. And the second part would be like this. Okay. And so first, before we can do this, we need to find the intersection points. Which are here and here. So how do we find those? So you don't want to set equal to 0 or anything. You want to set these equal to each other. So 3 cosine theta is equal to 1 plus cosine theta. And then what you want to do is subtract cosine on both sides. So cosine of theta equals 1/2. So when does it equal 1/2? It equals 1/2 at pi thirds. Theta equals pi thirds and 5 pi thirds. Okay, so those pi thirds and 5 pi thirds will be here. Okay, so the next part, we want to use a formula to solve for the area. So the formula we're going to use is integral to be 1/2 of r squared minus little r squared d theta. And then we're not going to do the limits yet. We're going to figure those out. And then next, we need to find out what big R is and little r is. So big R is the one further away. So if you want to go outside the second one, inside the first, the one that's furthest away, origin, is this big one, 3 cosine theta. So we want to do 3 cosine theta squared minus, and the next one, 1 plus cosine theta squared d theta. And so for the limits, we're going to want to, since this is symmetrical and this is pi thirds, we just want to go from 0 to pi thirds and double it. So we're going to double this area, and we're going to go from 0 to pi thirds. D theta. Okay, so we want to simplify this, and these cancel. We want to simplify this. So we have the area equal to 0. So simplify this, we have 9 cosine theta squared minus, and then we want to square this. So you have 1 squared plus 2 cosine theta plus cosine squared theta. And then what we can do is subtract one of the cosines. So we have 8 cosine squared theta minus 1 minus 2 cosine theta. Okay, so we want to, in order to take the integral of cosine squared theta, we have to write it as its other form, which is 1/2 1/2 of 1 plus cosine 2 theta, but it's times 8, so we want to have an 8 here. So it's 4 times this. So 4 plus 4 cosine 2 theta minus 1 minus 2 cosine theta. Okay, so the 4 minus 1, my mouse, 3 minus 2 cosine theta, the integral from pi thirds to 0. So now we have an easy integral to solve. It's always good to simplify the integral before you take it. So now we want to take the integral of this. So 3 would be 3 theta. 4 cosine 2 theta. We're going to get 4 sine 2 theta over 4. Okay, so this 4, it should be sine 2 theta over 2. This 4 is being multiplied, so it's actually sine 4 theta over 4. So no, the 4 doesn't go down there, sorry. The 4 sine 2 theta over 2. Then we have minus antiderivative of 2 cosine theta, which is 2 sine theta. And this is from pi thirds to 0. Okay, so now moving over here, we're going to plug in pi thirds. So we have 3 times pi thirds plus 4 sine 2 pi thirds. Well, we can simplify this to 2. This should be a 2. 4 over 2. These cancel to 2. So 2 sine. Okay, so now we need to do the integral of 2 sine theta. We need to plug it in. And this would be root 3 over 2. And then 2 pi over 3 would be root 3 over 2. This is sine. So we have that, and then we have plus 3 over pi thirds. Okay, so then these cancel, and you're left with the area being equal to pi.